Okay, the last thing that we're going to talk about is how we separate mixtures. So we're going to look at which properties and which techniques are the most useful in trying to separate mixtures of substances. So this is our learning target 30. You're going to be able to identify what techniques can be used to separate mixtures of substances based on their properties, and why is that useful? Why do we need to separate mixtures? Okay, so a mixture, remember, is a combination of elements and compounds that can be separated by physical means. There's two types of mixtures. Mixtures can be heterogeneous, which means it's not uniform. You can see all the parts of the mixture. Homogeneous are also called solutions. These are mixtures that are uniform and you cannot see all the parts of the mixture. So let's look at some examples. If we take this handful of candy, all the different types of candy, you can see all the different types. That would be heterogeneous because you can see all the parts. If we take a look at Kool-Aid, you cannot see all the parts inside this mixture, which is made up of sugar and water. You cannot see the individual sugar compounds, the individual water compounds. So that's a solution or homogeneous mixture. Pizza. You can see all the separate parts that make up a pizza. We've got black olives and pepperonis, which are my favorite on pizza. You can see the green onions, the peppers, mushrooms, which those three things are not my favorite. I'm pretty simple. I just like pepperoni and black olives. Since you can see all the parts of the mixtures, though, that is what makes it a heterogeneous mixture. If we look down at some other examples, milk. You cannot see all the different parts that make up the mixture of milk. So milk is a solution or homogeneous mixture. Ooh, yummy, this looks great. I would love to have this every day for breakfast. This is a fruit bowl. You've got all the different types of fruit, strawberries and blackberries, some of my favorites. And since you can see all the different fruits in the fruit bowl, that is a heterogeneous mixture. Salt water, you cannot see the individual salt compounds in the water. So that is a solution, a homogeneous mixture. Now, on to techniques. So there are a couple different techniques that we use to separate mixtures. Evaporation is used to separate mixtures only when there has been dissolving. So for example, salt can be dissolved in water. So we'll use evaporation to separate the salt and water. Okay, the physical property is going to be our boiling point is the physical property that is used with evaporation. So that's our physical property. Okay, so evaporation is only used to separate mostly solutions where there's been dissolving. Lemonade, sugar, and water, you can heat up the water evaporate, leave behind the sugar. Because salt and sugar have different boiling points than water, that's why we can separate them. So that's why boiling point's a very important physical property to use. Filtration is used to separate mixtures of solids, like different size solids, like that bag of candy. It also is used to separate mixtures of a liquid and solid that has not been dissolved. So the example we did with sand and water. Sand does not dissolve in water, so we can use filtration using those screens to pull out the sand and let the water flow through. Flour and water. Flour will not dissolve in water, so we can use filtration to separate flour and water. Same thing with dirt. Dirt is made up of a lot of different size particles, so we can use a screen to separate parts of dirt. Another technique that we use to separate mixtures is chromatography. This one you're probably not very familiar with. This is used to separate mixtures of ink, and we'll get to why that's important in a minute. So like inks on a check, to see if a check has been forged or not, we can use chromatography. So pretty much each type of pen is made up of different colors of ink. So if we have a black pen and we separate out into its colors, it'll make a certain mark like this over here. This mark is significant and it's unique to that type of pen. So that's what a black pen looks like. When a green pen goes through chromatography and we separate out the colors that make up a green pen, these are the colors, the blues and yellows that we see. A red pen, a lot of yellow, orange, and red makes up the red ink. So when we look at separating inks, we can find out who wrote what with which pen, which is actually what you're going to do in the lab, which is going to be a lot of fun. The last technique is distillation. It's used to separate a mixture of liquids or gases that have different boiling points. So if you have different boiling points, and they're all liquids, and they could be the same color, so we can't tell, like alcohol and water are the same color. I'm talking about rubbing alcohol. They're the same color, so if we mix them together, we can't tell how to separate them. But rubbing alcohol and water have different boiling points. So we can boil that mixture and separate them out. Okay, so this is an example of a liquid. You're going to boil it. Some of the liquid that is going to boil at that certain boiling point will come out. We can collect that gas, put it in a tube, condense it, meaning change that liquid that's coming out back in, that gas back into a liquid, and then we've separated that liquid from this mixture. So let me say that again. I don't think I said it very clearly. So this is a mixture of two liquids. We set it at one of the boiling points of the liquid. So we heat up the liquid. If water's in here to 100 degrees. Another liquid rubbing alcohol will actually, that will evaporate at a lower temperature, so I'll choose something else. But that water will evaporate, turn into gas. Then we collect that gas in a tube. Then we cool it down, condense it, make that gas go back to a liquid. Then it'll come back out and we'll have a liquid, and we've separated the liquids out. So that's distillation. This is used in the real world to separate crude oil to get the cleaner oil that we use for energy resources. It's also used to separate air into its parts. So air is a mixture of oxygen, nitrogen, carbon dioxide. So we can use distillation to separate it into its parts. Kind of what our lungs do anyways when we breathe in oxygen. Okay, so why is it important to know how to separate mixtures? What's the real world application? Why isn't this moving? Real world application for separating mixtures. Okay, I had a little trouble with my mouse. I'm sorry, I apologize. We separate mixtures in mining all the time when we want to get out the precious ores and separate and get out the minerals that we want out of the mining. We have to separate the copper, the gold, the silver out of the rock. So a rock is a mixture. We have to get rid of the parts of the rocks that we don't want and get out those precious minerals like I can't talk today, I'm sorry. Like gold and copper and silver. We also use it when we refine oil. When we drill for oil, we've got to separate the bad stuff out of the oil so we can get the clean oil that we use to run our cars. Another way that we separate mixtures is our water. We drink really clean water, even especially at Gilpin. We have very clean water coming out of our drinking fountains. It would not be clean if we did not filter out all the bad stuff that gets caught in water. So we've got to separate that mixture and get only the clean water out and separate all the bacteria or the protists or the extra dirt that could be found in the water. We want to get rid of that so we have clean water for drinking and showering and everything we use water for. So this just gives you a picture right here. This is separating in mining, how they separate gold from a mixture of dirt. Over here, this is a water filtration system, so it's separating out all the bad stuff that we don't want, the pathogens that can cause diseases. So that's why it's really important to know how to separate mixtures. Oil, okay, we heat up the crude oil, and the oil will separate based on the boiling points into different layers based on their density. And then we can get the type of oil that we want. Gasoline will form right here. If you look across the line, kerosene here. So this is what crude oil is all made up of. So we want to separate that out so we can use it for specific things. So the crude oil is separated using density and different boiling points. So that's the reason why we're learning about how to separate mixtures, is because we separate mixtures all the time. So they're really important in the real world.